Hello, welcome back to another, you guessed it, battery video. These are 18650 spaces which are 3D printed, and I printed them in two different colors. And I'm going to be building my first big pack. I know I built the 36 volt batteries. They were 10S 4P, that was my biggest, 40 cells, but this is going to be 56 cells. My first 24 volt system, so it's 7S, 1, 2, 3, 4, 5, 6, 7, and we've got 8 in parallel, 1, 2, 3, 4, 5, 6, 7, 8. And why 24 volt? Well, I have a lot of 12 volt packs. As you can see, there's one over there, another one up there, and there's more lying around. And a 24 volt pack is the sweet spot for lithium ion packs. The 3S pack is kind of just below what we need for 12 volt accessories. 4S is a bit too high, and 7S 24 volts is perfect. Like at full charge, that's 29.4, I think, 29.4, 29.2. Anyway, one of those two, and 24 volts sits well with things like Starlink Mini. So I can power my Starlink Mini with this. I can use it to increase the capacity of my EcoFlow devices, like this thing over here, because it takes a solar input of between 11 and 30 volts. So this sits well within the range from the low to the high. And something like my Delta 2 can take between 11 and 60, still in that range. So I can actually just plug this battery directly into the XT60 port, and it's going to pull maximum 8 amps and effectively charge it up at 8 amps. So if I have about 2.5 amp hour cells each, I'm almost going to have half a kilowatt. And the cells I'm going to use are these, and they've all been tested. They are second life cells from slbatteries.com.au. They're Sinowatt cells, 3.6 volt nominal. They're very, very good. I've used them for my e-bike packs and other small 12 volt packs. And now we're going to use them for my 24 volt pack. So we're going to use 56 of these. It's going to be almost half a kilowatt. We'll say half a kilowatt. $1 each, Australian, untested, but because it takes a lot, you can get them tested, but I tested these myself to get them at a cheaper price, and it took a long time, but I've got them all. And I wouldn't take too much notice of the internal resistance here because my device is not very accurate, so I'm just interested in the capacity. So about 2.5 amp hours each on average for each cell, and we're going to have a nice little brick of almost half a kilowatt. So 56 cells, $56, a Daly BMS somewhere, it's under here somewhere, I think it's right there. A Daly BMS for 24 volts, about 25 Australian dollars. So, and wiring and all that stuff and heat shrink. Let's just say for $100, I'm getting half a kilowatt hour of battery capacity. So what we're going to do is, hopefully I got 56 cells in there, but I've got more laying around. I'm going to put these through Cell Saviors, basically like a repacker type site, to make my pack all balanced. I'll do that because you don't want to go through that again. Quite a boring process. We'll do that, and I'll leap you back in when I'm ready to go to the next step. All right, look at all these batteries. So this shows you the spread of capacity. So these are 2 5s, 2 4s, 2 3s, 2 2s, 2 1s, 2 0, 1 9, 1 8. So we're not going to use those ones. Don't need to do anything less than 2 amp hours. And I'll pull 56 from here, but I got to write all these numbers down and input it into this website to give me a series configuration. Okay, you've seen me do this before. Here's the Cell Saviors website, 18650 pack builder, salvage cells, cell capacities, enter them all in there. Number and series, we've got 7, Number of cells in parallel, we got 8. Generate pack, and here we go. Right, 20 amp hours at 25.2 volts nominal, so almost half a kilowatt. And here's all my groups. So I have to group these and put them in a series configuration. Make sure that each cell group, each series group is really close together. So I'll do that and I'll leave you back in. Right, here's the pack. I'm going to put insulator rings on top just to be safe, and there's leftover cells which I'll repurpose in some other project. So I'll do that and get back to you. Alright, look at it. The batteries are off the floor and now arranged in the series groups as advised. 1, 2, 3, 4, 5, 6, 7, and 8 across. 1, 2, 3, 4, 5, 6, 7, 8. This is almost half a kilowatt. We'll call it half a kilowatt of energy. Wow. Wow. Alright, and I've put the insulator rings on them just for extra safety. So now I'm going to go check the voltage of each cell, make sure that they're quite similar, because when I start paralleling these, we don't want to inrush of current into a particular cell. That could be dangerous. Alright, as you can see, there's 4 holes here which line up to 1, 2, 3, 4. They were a little bit out of their cell group, so I'm going to give them a full charge, or top it up at least, before I parallel the connection. But while that's doing that, I can cut up my nickel strips, and we'll do all the the long strips first. So I'll need 14 of those. Alright, the 4 batteries that were a bit low, they're fully charged now. Started welding the parallel parts, going from the out to the in, because I want the pack to be stable, and this won't last the whole pack. As you can see, it's already down to 60%, but realistically, when that second LED goes off, it needs charging again. It's quite warm already. I did buy a DIY spot welder, which needed to be hooked up to a battery. I tried 3 different packs, different cells, still didn't work, because I wanted to be able to get through these packs without having to recharge it. Anyway, I'll keep going and I'll leave you back in as I go. Okay, I've done a lot more since the last update, but it's getting quite late now, so I'm going to leave it like this. The only thing I have to do now is make this a bit longer to make an XT60 connection, but I'm going to put 2 XT60 connections, so there's kind of 2 inputs and outputs. There's a Daly BMS, it's all wired up, temperature sensor there. Probably should stick it on a bit tighter. And there is the main positive, and there is the main negative. I'm getting better at doing this now. Yeah, alright, so I don't have heat shrink for this yet, because it's coming from AliExpress, but I'll insulate with some barley paper and wrap it up, and we'll do the connections tomorrow. Okay, it is now complete. No PVC heat shrink yet, hasn't arrived, but yeah, I doused it in fiber tape, and I'm really happy with how this turned out. Main positive, there's a Daly BMS, 7S 24 volt 20 amp, 20 amp for discharge, 10 amp for charge, and then we come up to an inline fuse, spread protection, 20 amps, and then we get a pair of XT60s, and I just have one little inline voltmeter, 29.3, so that's fully charged, and it is quite a beast, half a kilowatt. Really happy with that. So let's test it by topping up one of my River 2 EcoFlow power stations. Okay, it's attached to the EcoFlow River 2. There we go, because the solar input takes between 11 and 30 volts, so perfect range. You see the voltage is going down a bit, sagging because of the draw. And it is at max 8 amps, I think, 108 watts. So we get half kilowatt of storage for $100, and I can use it on any 24 volt system. It's perfect for charging power stations and Starlink Mini. And I forgot to show you that I did end up printing up the label. I'll print another one on top when it's heat shrink. So people that do have this, especially myself, know that it's actually a 24 volt pack. 19.541 amp hours, 492.43 watt hours. We're going to charge my 24 volt pack with this AC charger. This was given to me by AliExpress. Thank you very much. Output 29.4 volts, 5 amps, and inputs between 100 and 240 volts. So you can use this adapter worldwide. It's not that heavy, but it does have a fan, which is good. It's active cooling. And I got the XT60 connection, and we have an IEC, what's this, C13, C8, I'm not sure what these ones are called, and AE plug, only 2-prong. So if you in another country, you can just select the right cable for your region. So when I drain my pack, we'll charge it up and we'll see how it goes. Okay, the battery pack's now connected to my River 3, and interestingly enough, this can take a bit more current, almost double, so it's taking it in at 216 watts. That's pretty good. Right, just been out for lunch, come back, and yeah, it's pretty much fully charged. And let's have a look at the voltage. Oh no, it's actually empty, so it actually cut out. Let me take that voltage manually now. I plugged the solar back in, so that will charge it back up again. Solar panel's 160 watts. And yeah, it's good. I've actually fully drained the pack, so I'll be able to test the charger out and see how we go. Alright, we're charging it in the garage because we're going to charge it from my King's setup here. It's pretty full, as you can see, we're at float, so we're going to pull some power from it to charge this back up. Got all these connectors in here because it's going through the inline meter, so we'll see how much the charger pushes through to the pack. You can see it's reading 29.6 volts now. Now I just got to plug it in. Okay, as soon as I plug that in, the fan's going, and we're pushing 111 watts into it. So almost 5 amps. It is a 5 amp charger, so that is very good. It's doing what it does. Yeah, I need to tidy up this place a bit. I've got it on this Tapo smart plug to turn off after 6 hours in case I forget it. It's also got energy monitoring built in. So I recommend that everyone who does have to charge lithium batteries get a smart plug, because yeah, you want to be able to turn it off remotely or automatically just in case. And mine's always set to auto turn off after 6 hours. And the inverter is kicked in here because it's detecting that I'm pulling a load. Alright, we'll check back in a bit later to see how much I push into this pack. Okay, just an update, still charging. We're at 28.14 volts now, and we've delivered 14.732 amp hours, 385.3 watt hours. Double check the specs, so we're going to get to 19.541 amp hours and 492.43 watt hours. Okay, it looks like we're in the constant voltage stage because the current has dropped to 0.52 amps. We're already at 29.55 volts, and we've put in 524.5 watt hours, which is over 19 amps already. So I'll leave it for a bit longer just to taper off, and we can consider that fully charged. And I was just in the garage and I heard it stop, the green light's on, and we are finished. So it's down to 0.34 amps. That's kind of like the trickle current. I'm really quite happy with the versatility of a 24 volt pack. I didn't think, I thought it would be much more inconvenient to be using 24 volt packs because I'm going to step down to 12 volts, but most of the stuff that I want to use it for, I don't need to do that. But yeah, I'll be making more videos in the future about 24 volt systems as I learn them, and I'll bring you along for the journey. Okay, it's taken like a week or so, or yeah, it's taken a while, but I finally received the PVC heat shrink. It's quite big, but it should fit in, but hopefully it shrinks down. I'll let you know when it's done. All right, here it is. It was quite big, so I kind of wrapped it 3 times in the heat shrink, and it's still too big. But anyway, I had this old microphone condenser mic case, and I've just repurposed it. Put some foam around the outside and drilled a hole at the front. And there we have it. Now we're going to weigh it and see how much it weighs. We're in the bathroom. Zeroed it out. 3.6 kilos. And I fed my voltmeter through. Just leave it like that. And there's the other input and output ready to go.